Beginning transmission. This is the Chaos Community Broadcast, a show about failures and how to navigate complex socio-technical systems so you can surf the chaos instead of succumbing to it. For a recording of this broadcast, as well as all of our previous broadcasts, go to a web browser of your choice and type in chaos.community. I'm your host, James Wickett. I was excited for this episode because, we don't have any guests this episode, and Casey's interviewing me, so I'm sure he's just, running a little late or something. So we'll hang out here for a second. Oh, getting a text from Casey. It says, LOL, you thought I wanted to interview you. Okay, yeah, well, should have thought that would, getting another text, actually a lot of text. It's just a crying eyes emoji again and again. There's got to be like 50 of them here. Okay, yeah, well, that's all right. I've got some other footage from last season from the show that I've been working on putting together, and maybe we'll just run with that for this show.
I don't often use the word brilliant, except in self-affirmation. I pride myself on being selfish taught. That's a phrase I learned from Ayn Rand when we were on a panel together, competitive shrugging.
Let's show some highlights from season 1 guests. If YouTube stats are to be believed, most of you missed season 1, and missed might be a bit of a strong word here, but let's get into our first guest. We started the show talking with one of the contributing authors of Chaos Engineering, the book. We started first with Nathan Aschbacher.
So we're kicking off this series with authors from contributing authors from the Chaos Engineering book, and you wrote a chapter in that. Congratulations on being published. Yeah, have you read your chapter?
I wrote it, and then I had to read it before it went to production. I had other people also read it, and we were all fine with it.
Nathan discussed cyber-physical systems with us, and the amount of crossover with IT software systems, it was really interesting.
So probe effect is something that's fairly common, a common consideration in, say, like electrical engineering or electric circuit design, where the instruments that you use to measure things actually have an impact on the measurement, right? They don't exist in a vacuum. You can't take a perfect, cost-free measurement. There may be some like current draw from the tool that's being connected to the circuit. And I think the concept is sound. It's been used in a lot of other domains for quite a long time, and it maps to the software world pretty well, right? If you turn on if you turn on tracing in the Linux kernel, for instance, it has a performance impact, and it might actually be that it's the performance impact that's causing the problem that you're observing in some cases. And so trying to put boundary conditions or trying to establish that whatever effect it's having is not having an effect on what you care to be measuring is a really important part of trying to understand whether or not your testing is the problem, rather than the system that's under test.
Also in this episode, Old Man Rosenthal made his first appearance in the broadcast. And personally for me, this was a moment that I realized I might have made a mistake putting Casey on TV.
Yeah, this is a visual cue for people to indicate that you've been talking for a long time about potentially boring things. Continue.
Too long. That's a good visual cue. I like it.
We brought in Nora Jones from Jelly, and it was one of the most viewed episodes of the show. Nora's an expert in facilitating discussion around incidents, and we dive in here to discuss. And here's a highlight from that conversation.
How does one become a really good facilitator?
Yeah, it's a good question. It's not being the expert, but being able to dig into things in different words that someone tells you about a situation. So if they're if they're saying, yeah, this part of the system is very flaky, not being like, oh yeah, I know that tipped over last night, even though you do know, asking them, oh, what do you mean it's flaky? Can you elaborate on what that word means? And I know that can be kind of awkward, especially with folks that you've worked with for 3 years. I remember in a post-incident review once, I was asking someone what tool they used to make a configuration change. And they were like, Nora, I made a change with you in this system like a couple weeks ago. Like, they were just looking at me. I'm like, well, humor me for a second. And I think being a good facilitator is all about being able to kind of remove that ego and ask some of the silly questions that you might know the answers to, but it's really not about the canonical answer, right? It's about how someone else views the system, because then you can see the gaps between how they view the system, maybe how you view the system, maybe how other people in the organization are viewing that system. And you get to see how you actually work versus how you think you work as an organization. It kind of bubbles things up to the surface that folks have maybe been ignoring, that folks didn't actually know exist, and it creates learning opportunities in the organization.
It's an interesting answer. The canonical answer is actually read the book, but that was an interesting answer.
Yes, I put a large set of questions in the book to help you become a facilitator.
But is there anything in particular about your outlook on software, your understanding of where the industry is, that you feel has contributed to your success?
I mean, I've been so lucky to work with amazing people at each company I've been at. I mean, Jet was kind of a startup environment. I was in hardware before Jet, still focused on reliability, but it was a different journey for me. And I was able to take some of the same theories and approaches towards hardware reliability. And I was actually surprised how much it applied towards software as well. And honestly, just collaborating and getting to know teammates. Like one of the things, so I studied computer engineering back when I went to school. And one of the things I really disliked about the major was how individual it was, how I felt that it could be a lot more collaborative. I felt that we were going to build better things if we were working together, if we were talking. And I think sometimes the software industry falls into that trap as well, where you put your headphones on and you just code all day. And I think actually sitting down and working with my coworkers and building reliability tools and really thinking about the business impacts of things has just completely changed my viewpoint and, has really helped me along this journey. Yeah, I'm still going, but it's been so fun.
So then we took the show on the road for episode 2 as Russ Miles, another contributing author to the book, kindly invited us into his home across the pond. Let's listen in. Cheerio.
So you are a chaos engineering expert and the author of the chapter Open Minds, Open Science, and Open Chaos in the Chaos Engineering book from O'Reilly. Congratulations on being published yet again. Now, in the book, you stress the importance of openness and collaboration to avoid chaos engineering teams being perceived as just an outsider that wreaks havoc in the system. Can you give the audience at home a teaser and expand on why that's important?
So I can certainly say why I think it's important to me. And that stems from when I actually first read one of your first books, which was around chaos engineering as well, the Chaos Engineering Report for O'Reilly. One of the striking things that was put to me in that book and reminded me in that book really is the scientific nature of what we're doing. We don't do chaos engineering because the actual engineering of chaos or turbulent conditions is fun, although it can be, but you have to be pretty sick, I think, to find it fun. We do these things because we learn from them. And I love actually Nora's quote from the book that we've just put out around, we're hunting surprises. And for me, that's what we were doing. We were hunting surprises through a controlled scientific process.
As the conversation unfolded, we addressed thrilling topics like ugly O'Reilly book covers. Russ broke out the guitar, and we found our way back to humans in complex systems.
Can you expand on that? Why is human error always at fault?
Oh, that's a inflammatory phrase. Human error is given the fault because it's an easy get out of jail card.
Oh, wait. Yeah, you're right. I read that wrong.
Julie Gunderson from PagerDuty joined us and discussed growing DevOps practices and where chaos engineering and DevOps practices fit in with overall DevOps adoption.
Right now, you manage the DevOps program at PagerDuty, or what's your official title there?
DevOps advocate.
DevOps advocate. So does that mean that you advocate for the DevOps people, or you're an advocate of DevOps as a practice?
I'm an advocate of DevOps as a practice.
What is it about that practice that attracted you to that line of work?
It was the knowledge sharing. It was the people. It was the reducing silos, and it was about the culture. I think that's what got me most excited. The first people that I met in tech were all in DevOps, and really wanted to help me learn and me be better. And I love sharing that with customers and other people on how you can just make your businesses better. Baby steps.
Do you have because you've been doing this for a while, do you have any particular patterns that you see when you first meet a new customer of an area of focus, or a way you like to start your approach in communicating with them about DevOps and passing forward that culture that attracted you to the field in the first place?
Yeah, actually, when I'm talking to customers, I often like to just ask what their processes look like. How do they communicate with people? Sometimes I get really frightened when I hear the terms ITIL, similar to how I feel about bears. But understanding how they make their organization a learning organization, oftentimes even the customers that feel that they're the most mature don't have some of the basic practices in place, such as postmortems, or they use terms like root cause, and we try to talk about the language that matters. And that actually kind of goes back a little bit to chaos engineering. We talk about language, like executives don't always love to hear the term chaos or failure. And so thinking about how you communicate, and that's one of the things that I love working with organizations on is how to communicate and learning how to start small. Sometimes they think that they can just change everything. Oh, we're going to do a cloud migration in 2 years, just boom. And, explaining that you might want to add a 0 to that.
And, Casey needlessly promoted the book with lots of guests.
Anything stand out on your bookshelf?
Into Thin Air by John Krakauer.
Okay. Unfortunately, that's the wrong answer. O'Reilly's Chaos Engineering book is what we were thinking of.
This shows that only a complete shill would continually promote the same book over and over and over again. And what is worse, continually remind people that they can get it for free for a limited time at verica.io/book. Episode 4 was a little bit embarrassing for me because John Allspaw is one of my heroes, and
James, dude, this is not what I expected.
Even so, John Allspaw dove deep on automation.
The plain, simple fact is that people are making businesses work, and they're doing it continually, all the time. And taking people out of positions that they're in puts most systems, all of business critical systems on a precipice. And it's because of what people are continually doing, watching out for, integrating with what they are seeing as signals, reacting to and anticipating a whole bunch of potential outcomes that never come to pass because they are there, because they're in the breach. And automation is necessary. It has to be there. But it doesn't come for free, and the gist in the chapter is that humans are the adaptive part of the system because they can handle things that weren't anticipated.
The episode with John is full of other classic moments, and we've received numerous letters from viewers on this episode alone. Well, at least one letter. It might have just been a tweet, but either way, it was definitely the most audience engagement we had by far. Casey and I often didn't see eye to eye, even about what questions we would be asking the guests. Casey, I thought we agreed not to do this bit. I thought we scrapped that.
Ignore him, Crystal. So we'll cut that in post.
Even so, Crystal Hirschorn did a great job uncovering what it takes to get chaos engineering adopted at the VP level. So let's listen in on that conversation.
So we sometimes hear that people are turned off by the name quote unquote chaos engineering. Large organizations don't want chaos, they want predictability. Did you ever find, being in upper management, that everyone was on board with adopting chaos engineering except the stodgy, risk-averse engineers?
Well, I mean, it's funny you say that, because some engineers also can be quite hesitant to terms like chaos. And, I think it's still, even though chaos engineering's been around a while now, it can still seem quite new to a lot of people. Even within engineering, I still find myself having to explain what it is quite a lot, particularly when I was trying to get it adopted at Condé Nast.
Dr. Peter Alvaro discussed some of his research and how chaos engineering impacts the computer science field. Let's listen in on that.
So if viewers want to donate to Disorderly Labs, do you have a GoFundMe set up or something like that?
I don't, because I don't think we're actually allowed to accept donations in that way. But if you are interested in supporting my research, come talk to me. You'd be in good company.
In your paper, Abstracting the Geniuses Away from Failure Testing, published in the Communication of the ACM in 2018, you write, existing failure testing solutions require skilled and intelligent users, which sounds like a compliment, who can supply the faults to inject. These super users, known as chaos engineers and Jepson experts, must study the system under test, observe system executions, and then formulate hypotheses about which faults are most likely to expose real system design flaws. This approach is fundamentally unscalable and unprincipled. And then later on you call us the old gods. So I'm getting mixed messages here. Are we chaos engineers gods, intelligent, old, unprincipled? Are we the baddies?
Okay, so let me, unprincipled. Important to remember that that paper is a polemic piece. It's using direct argumentation rather than evidence or whatever. And so overclaiming is not the right word, but we're coming in strong in that paper, trying to get people's attention. And the hope is that, and this is a style I do all the time actually in research, is like a little bit of overclaiming in the abstract or introduction so that principled readers will go, oh, I'll believe that when I see it, and then actually read the paper. As I get into in my chapter, expert level SREs are essential. But it's very hard to characterize. Like, certainly they have some mental model of the system that they occasionally discharge intuitions from, and that mental model surely was built up by being around, having experience, watching the system. But it's very hard in general for them to train, or even for that matter, explain the process. I know this for a fact. I've spent the last couple of years interviewing SREs at big companies and saying, okay, walk me through these incidents. Like, what do you do first? Then what do you do? And so, I don't think it's totally unfair to characterize the process that is applied in incident response and in, experiment selection as, you've read Plato's Io, right? Like, a god speaks through me.
In episode 7, we brought on a very special guest, because we have with us the orchestrator of Chaos Community Days London, the global head of Amazon Video Availability and Scale, the crowd goes wild, Olga Hall.
It's an honor and pleasure to be here. Thank you for inviting me to be on the show.
That was a bit much, James.
You told me to spice it up.
Yeah, I did, but that was a bit much.
It turns out, as it often does, that Casey was wrong, because Olga shared where motivation and goals for chaos engineering and experimentation fit in.
Why are you doing this, right? What do you really want this experiment for? And if you're running experiments because you already know the answer, and the answer is the system will fail, then it's not worth it. The hidden little gem in chaos engineering is that you have to know your whys, you have to have your hypothesis, and you have to have tested and prepared and have ready the fallbacks so that when you're running your experiments, you're basically figuring out which of these fallback paths and which of these fallbacks work best under which condition. And I think that closing loop on fallbacks and having visibility to all the way from hypothesis to experiment to what have we learned and what are the actions that we're going to take from this, that last part sometimes gets overlooked.
That episode is full of other valuable learnings, but let's go ahead and turn on to episode 8 with Miko Pawlikowski, a book author and a practitioner of chaos engineering at Bloomberg. And he joins us and we discuss a hot button issue.
So what do you recommend to people who have read the blogs or seen marketing material that they should break all the things?
Well, first point would probably be to stop calling your outages breaking things on purpose and production. Second point, you're right. Like I hear this all the time, and I actually consider getting a T-shirt with, saying, no, chaos engineering isn't breaking things randomly in production. I think that, if you actually were interested in an honest answer, it'd probably be that applying the same principles that you do to deploying your software should be also applied to the way that you do chaos engineering. You can probably get fired for releasing buggy stuff directly to prod. I don't see how that's different from doing chaos engineering directly in prod. But there's definitely less sexiness if you don't include that in your presentation, right? So I don't think that's going anytime soon from all the flashy and nice blog posts with a little mountain in the back and some good, stock footage. So
Observability expert Liz Fong-Jones joins us for the next episode. We asked Liz, how does observability differ from monitoring?
I think that question is predicated on a couple of misleading assumptions. First of all, it is true that companies that have previously been selling monitoring solutions are attempting to rebrand themselves as observability. But I think that for your enterprise that has been using these monitoring tools, the rename has done absolutely nothing to change what those tools are doing if you are stuck using legacy tooling. So I think that is part of the reason why there are a lot of folks who say observability is hype, observability doesn't actually do anything differently, right? It's because people are just rebranding in place. We saw the same thing with DevOps, where people would practice the same old shit and then they'd just slap the DevOps or SRE labels on them and say, it's now SRE or DevOps, right? I think that the place where companies realize that they do need something different than what they've been traditionally sold or building in-house is when you get to that point of having chaotic, complex systems, as you're saying. Right, at that point, no amount of measuring your known unknowns will help you navigate your unknown unknowns. And I think that that's where people start seeing this need, regardless of what you call it, for solutions that involve being able to ask any question, to be able to unpack and understand exactly what's happening with your unknown unknowns.
Okay, now let's move to episode 10 with Andy Fleener, where he brings in some of the flavor for his chapter of the book on humanistic chaos.
The experiment is designed to sort of give you an understanding of the system, right? So like the first step is getting the steady state. And so the work to understand the steady state is actually one of the most important pieces. Nora describes that in her chapter really, really well about the beginning of the experiment. And that work actually pays off even if you don't do the experiment. And I think that's the part that people miss, is that the work to decide what experiment to do and how to actually do it is some of the most valuable work you can do. Because you have limited resources, you have limited time, so you have to pick things that will make an impact.
So if you work on doing the work to do the work, you might not have to actually do the work to get the benefit from it.
Ah, that sounds like the Casey who we've come to know and love throughout this season, or some of us have. Next, from the Vanguard, Christina Yakomin, how do you build a chaos engineering organization and show value?
It's been a really slow burn, and it was definitely brought in by the engineers doing the work. Very much a grassroots movement that came from the bottom up. We had just a couple of engineers who were really passionate about SRE, and then by extension, that focus landed on chaos engineering. And we really made the pitch from nothing, from almost no funding to getting to where we are now, which is a team of 6, to where we're going to be next year, which is going to be doubling to a team of 12. And all of that was through, writing some initial white papers, presenting that, getting just a few people on board to buy into the value of chaos engineering. And then from there, iterating and demonstrating value every single step of the way to get that next level of funding out of upper leadership.
And that concludes our show. I'm literally still getting emoji, just emojis from Casey. So next time. And that's our show. For recording of this broadcast, as well as all of our previous broadcasts, type in chaos.community into a web browser of your choice. Ending transmission now.